is 1, 2, 3. So once we wait until 2045, that'll be a really fun day. Because then it'll be 1, 2, 3, 4, 5. But to say this and have it in the video before anybody that might watch this might wonder if I'm just nuts, my beard and mustache are colored today thanks to our wonderful mathletes, Megan, Max, and Calvin. Deserve a huge congratulations because they were 75% of our A team that brought home the gold medal.
Nice job!
Wait, how are two people?
Now,
75?
unfortunately, no, Megan, Max, and
I
Calvin.
thought you just said Max and Calvin.
No.
75.
So, Michelle got sick and she actually wasn't able to come to contest with us. So, a 7th grader who's in Math 1, his name's Chris. Sorry, I try not to connect first and last names on my videos, but he stepped up onto the A team. Fortunately, everything worked out really nice. Everyone was really cool about it, and then we had a perfect 4-person A team and a 4-person B team. Math counts can happen today, right? Megan, are you going to be here? Yes, maybe?
Yeah, today.
Extensions? Yeah, I'd like to start going over the results and answers and everything. So, if you're curious about what we did, feel free to come to Math Counts today, and we will be going over our packets and everything from contest, checking any of our mistakes, etc., etc.
Wait, you did the packet back?
Oh yeah, I got them all right here. Yeah. So I have not even looked. I also had a really interesting thing to tell you about how we beat McCord. I have not checked how close the points were. If we only won by 1 question, we really won because they made a really simple, a silly error. Not a math error, but in general a silly error that they should have known better.
What was the error?
So SAT versus ACT, and don't quote me on this because I have not taken the SAT in a long time. I heard it might have been redesigned, but back when I was in high school, the SAT, you get positive points for getting questions right. You get no points for getting a blank, like leaving the question blank, and you get points deducted for getting questions wrong.
Yeah, they switched it up.
On the ACT, getting it wrong and leaving it blank are the exact same thing. You just don't get credit. So on the Math Counts test, the other team could not agree on an answer, and they went back and they erased the answer they had written down because they were still debating. They never went back and wrote an answer down. The answer they had written down initially was right. But then they erased it and never wrote one down. They got it wrong.
Wait, who was on the McCord team?
I don't know.
I know Philip White.
Hey, stop. It's recording. Stop. I don't like first and last names connected in my recordings. Which actually, I taught Philip 2 years ago in summer school.
Yeah.
Which is why he's in Math 3 now. Which
He's in
I thought was a bad idea to begin with. But whatever. So, when we look at graphing parabolas, it's actually used to model real-world situations. So, this diagram shows the plan for your new garden. I built gardens like this in my backyard. Lots of people have raised gardens so you can have really nice soil. Ohio's got really clayey soil, it's really dense. So a lot of times you buy some nice garden soil, make a nice garden. So we have that the height is 4 inches. It's going to be 2x yards long and x yards wide. So it's half as wide as it is long. So if we want to set up an equation for volume, we're going to have length times width times height. Because we want to know what volume of soil do I need to buy in order to fill this entire garden. Because you buy soil by volume. It's bagged, but it has a volume. Yeah?
You're given the amount of soil. You need to figure out the dimensions.
Do they give us the amount of soil?
Yeah.
Yeah, 1.5 yards. So, first, when I set up length times width times height, because we'll get to plugging that in, I've got 4, 2x, and x. So, that really tells me that my volume, when I simplify that out, is 1, 2, 3. 8x squared. And that is equal to 1.5 yards cubed. Now, a cubic yard, please understand, is very large. 3 feet by 3 feet by 3 feet. Literally a 3-foot box full of dirt. So that's a lot larger than people realize. How can I solve for this? Well, the algebraic method of isolate your x would tell me the first thing that I would want to do here, if this was algebra. Let's say this wasn't even x squared. If it was just 8x, what would you do to get x by itself?
Divide by 8.
Divide by the 8. So we first divide by the 8. No one's going to catch me. No, there's something way back.
Ah! 4 inches. Got you.
Yeah, but I had to ask for this one. Can I use inches, yards, yards?
No.
I'm going to end up with inches, yards squared. That's not a unit. So if this is yards cubed, I need to make sure that this is yards cubed. We should not have used 4.
Would it be better to change the 4 into like a version of yards or the yards into inches?
Ooh, so that's the question. And we can do either. So better is like relative to what you think, right? So here's the thing. If I make my coefficient smaller than 1, I'll actually multiply on both sides to work my solution process. So here, we actually would not have the 8x. This 4 would have actually been, well, how do I convert 4 into yards?
Well, 4 inches is a third of 1 foot, and yeah, there's 3 foot in 1 yard.
How many inches are in a yard?
36.
Make that
36.
jump.
There you
36.
go. I have a different method.
So this really becomes 1/9 times 2 times x, which makes this 2/9 x squared. So actually, we multiply by what to get rid of the 2/9?
9 halves.
Multiply by its reciprocal.
Now you're multiplying.
Do it on both sides. That will give me x squared equal to, sure, because that'd be 13.5 divided by 2. Yeah, it should be. And then, to undo a square, we got a square root. And we just get that x, sorry if you're watching the video, you totally can't see this right now, equals radical 6.75. Yeah, Scarlett and Michelle, they're at Thomas doing the band thing. Now this would be radical 6.75 yards. So whatever answer you get here, that's in yards. Did you do the radical?
No.
So do radical 6.75 for me. But then it's going to be a really weird number.
2 point. Should I just round?
But,
Yeah, it's like 2.6.
so hold on, leave that in your calculator.
Yes.
Because then we can make this easier to deal with. Instead of dealing with a really awkward amount of yards, if this gave me inches, I mean, I could plug in my x as yards, but I could also convert it out into inches if I wanted. So I could take that value and multiply by 36.
And then you get another awkward number.
You
Oh,
get
but
like
it's better to
93.
work with. So what is it then?
93.53.
So 93.5 inches. So this, if we converted it, is about 93.5 inches. Or whatever value you got for x as yards, but in the real world application, you'd probably then work in inches because it would be easier. Your ruler, your measuring tape, has inches. It doesn't tell you yards. Can't think of any, well, I'm sure there are measuring lines that do yards, like for football and everything else, that are marked in yards, but most measuring devices are inches or feet or something like that. Dang it. Alright, so my board is off orient, so that did not get captured. But, so, when we look at any function that has a constant term being added or subtracted to it, like our x squared minus 1 right here, what does that do to it? Any constant being added or subtracted. So this, x squared minus 1. If I just graph x squared, my input, then I square it, and I get my output. So if I make a table of my f of x, my output, when I have input x, actually I'm going to do my input x first. So let's do input x and f of x, which is x squared minus 1. Well, if my input's 0, 0 squared 0, I get negative 1. I can place my first point on the graph. If I input a positive 1, 1 squared minus 1, I get 0 as my output. That would also work if it was negative, because when I square something, yeah, Lynn? So, my function up here is the x value squared minus 1. So I'm taking whatever my x is, square it, and then subtract 1 away. So 1 squared is 1, minus 1 gives me 0. Negative 1 squared, well, whether it's positive or negative doesn't matter because of the square. So I get the same thing. Same thing when I look at 2. If I did 2 squared, that'd give me 4 minus 1 is 3. Or negative 2 squared is 4 minus 1 still gives me 3. So what's nice about parabolas is because we use the square, my x, my input value, as long as there's no b in the middle, can really be positive or negatives, and I get the same outputs. Because my x, the only thing happening with it is it being squared. Now, if there was like plus 3x or something like that, then the positive negative would matter if there was a b value. But right now, all we have is our a and our c. Because there's no just x. We have x squared and then constant. So from there, I can actually graph this. Negligible. It's so small, it's easy to get like close. So if we did that using just x squared, well, then I wouldn't subtract 1 from any of them. So how can I take the points on this graph and really make the points on this graph? Right? Just move it up 1. Yeah, instead of subtracting 1, add 1 back to your y values. So we're there, there, and there. Or there, there, and there. Now my orientation's kind of goofing with me a little bit. This is, I don't think it's going to let me. Yeah. And then for x squared plus 1, we could take our blue graph and shift that up 1. And actually, these points are going to end up off your graph. So let's discuss this for a second. What value of x for my red graph made this true? That x squared minus 1 was 0. Because we have the table here. Okay, right?
1 and negative 1?
Yeah, positive 1, negative 1. In my blue graph, or graph B, what value of x made that true?
0.
And you can probably guess is there a point on that graph where x squared minus 1 equals 0? Or, sorry, x squared plus 1 equals 0. Anytime I square a number, I'm getting a positive. And then if I add 1, I'm getting an even bigger number. So what Calvin's saying is, well, what if it's I? Why are you thinking I?
Because I is the square root of -1, so if you square it, you get -1.
So then, if we say when x... No, not yet. It's fine. This is not like something you're supposed to have in your back pocket that you can just pull out. But what we're really actually saying is I would need to have the square root of -1 because this, we'll square it, that would undo it, and we would get -1. And then we would add 1, and -1 plus 1 would give me 0. But the problem is, when I go to do the square root of -1, this doesn't exist. Because you can't square root a negative number. Let's talk about conceptually why this is.
Are we
When-
doing imaginary stuff now?
Kind of.
I is the imaginary number.
Yeah, it came up on the map.
Yeah,
and I got
I didn't know it did.
Yeah, it comes with free. Like past like 5 times.
It was like I plus I.
Let's talk about why this doesn't work. Let's talk about why this doesn't work. Square roots, at their core, deal with... We good? 'Cause, I mean, I can wait. I'm not, like, being jerky. I'm just saying, like, cool? Square roots are dealing with squares of area. So, if these are our areas, then the edge length is your square root. So, my edge length is radical 4, becomes 2. My edge length here is radical 2. It becomes this messy number that's like 1.41, yada yada. It's a great, awesome, it's not a perfect square, but it's a fun number, radical 2. 1, well, okay, square root of 1 is 1 because 1 times 1 is 1. Awesome. But what this is saying is we have a square with an area of -1. What would be your edge length? You can't have a negative area. It doesn't make any sense. So we have invented, or not really we, but mathematicians way back when, have invented this imaginary number that doesn't exist. Like, we know it doesn't exist. We can't use it. But to represent the idea of square rooting a negative value, we introduce this value I, which represents radical -1. So now, not that you have to have it memorized or able to use it all the time or anything, you want somewhere on your notes to notate that I is the mathematical value for the square root of -1.
Question.
Right.
Is there any like practical use for this?
Depends on what you mean by practical, but yes, there will be times that we need this in order to be able to solve certain situations. Because certain parabolas, one solution's imaginary, the other is actual, and we can do it. Like, there is a solution as opposed to two solutions. So one solution in quotations, is imaginary, and the other one is an actual number, not imaginary. It's real. Okay.
How come on like certain, like on the map, it was asking me to do multiplication with a number that has no case in like a real math?
I'd have to see the problem. They're
It was like
really
it's
awesome.
It's expressions that
Like how would
use
you
the
work
number,
with it?
use the
Yeah, like it
letter
doesn't.
I.
It's just like two
It
I.
just represents the square root of -1, so you treat it as such.
Okay, well then, so 2 times the square root of -1 plus 8 times the square root of -1 equals.
10 times the square root of
But
-1.
that wasn't the answer. That was like 13. It made no
How
sense.
do you know what the answer was?
Because I mean, all I know is it made no sense. It had nothing to do with the coefficient in front of it. It was just random,
It wasn't
wazoo
random.
stuff. It didn't make any sense.
So next time you see it,
Right
see if or just see if it makes more sense now that we've had these conversations.
Okay.
Because if you don't have any schema, you might look at it and be like, well, this is just stupid. But now that you have some background knowledge, you can be like, oh, I still don't totally get it, but I kind of see what they're going for. You know, like,
Okay.
So next time you see
write
it.
down the problem and then I'll show it to you and see if it actually
Yeah.
makes any sense.
So there is also an algebraic method to solve all of these, especially when it came from a difference of squares. Bless you. So remember, our difference of squares was where one had a positive and one had a negative. So this would have been x plus something, x minus something. So my outer and my inner could cancel out. The algebraic method to solve these values, how can I isolate the x squared? We're going back to simple, and then we'll get back to complicated. I know some of us are giving me the like, this is kind of boring look, but we've spent a few days on the really tough stuff. Now we're back to a little bit easier to ease us back in. Calvin?
Add 16.
Add 16 to both sides. We get x squared is 16. What squared could give you 16? Well, obviously 4 would work, but also
Negative 4.
negative 4. So we see that this gives me the solution of x is negative 4, and this gives me the solution of x is positive 4. Now, we don't actually have to factor it at this point, but this is where we get those solutions from. I'm trying to make you guys see like where everything fits together. And it says use a graph, but we could take our graph of the parabola, shift it down 16, and figure out where it intersects, and it would be my x values of 4 and negative 4.
You know how much you want us to graph?
At least understand how you would graph it. So you guys know that I'm pretty easy with my expectations for you guys. If you understand what you're doing, then you're okay. Let's flip to the back. I cannot reach that little doodad thing. Sorry, you probably can't see the square that it cut off on the top here. So this is 3x squared minus 75. So if we were going to graph this, we're not going to, but if we were going to, what two things have happened to my parent function? My parent function just being x squared, the original graph, right?
Well, the 3 would change how wide it is, and the 75 would change up and down.
Does it make it more wide or more steep?
More steep.
More steep, right? Because it climbs higher faster. So it makes it tighter. So this has been shifted down and brought in. Now, if we solve this algebraically, what would be the first thing that you do to both sides?
It would add 75.
Add the 75. So we would end up with 3x squared equals 75. The next thing that we would want to do here, divide by 3. We get x squared is 25. Now be careful.
5 and negative 5.
X is positive or negative 5, which you can use that symbol if you would like. Any issues up to this point? Cool. Okay. Tried, they got it. Should be able to get this pretty quickly. Why? If I just oriented you, are you not going to let me do that?
Canada.
What are your M values and your got it? Your solutions are 6 and negative 6, right? Because it's gotta make a positive 36 when squared. So now let's talk about choosing a reasonable solution. So my buddy Matt, whose dad now lives down in Florida, if you ever go to the Keys and would like to rent a boat, let me know. I can probably get you a deal. I'm not even joking. That's if I've ever talked about Captain Jack, the parrot thing. Yeah, he lives down at the boat rental place now. So they used to build aquariums. They were super big into fish and saltwater tanks, and you can make lots of money if you know how to grow coral. different things like that. So they made a bunch of money off this. But when you're building an aquarium, sometimes you know the volume that you need for a certain type of fish or certain type of aquatic plant or whatever else. So they say that the volume of this tank needs to be 420 feet cubed. Now, cubic feet are foot by foot by foot, so smaller, more easy to deal with. If we know that it has to be 3 feet tall, and we really don't know anything, well, we know the length is twice the width. I want you guys to try to set this up on your own and solve for the possible length and width of the aquarium. Oh my gosh. Do you guys even know why that's related? The actual reason?
Oh.
Not an clue. I just saw that's a meme.
Yeah, so this is my frustration when people laugh at things they don't understand. So our very mature gentleman over here laughing at 420 because it somehow relates to marijuana. That is because in California there's Proposition 420, which is the law that put it into legal use.
And then there's a time.
Yeah, that came after.
Yeah.
So the real history of why most people laugh about it and they don't know why is because that was the number of the proposition.
You like to look that up?
No, that's it. Once you like learn things about the world, that's one of those like, why do people chuckle and laugh about 420? Why is that national? Whatever. It's California Proposition 420. Now, regardless of where you are and whether it's legal or not, it's bad for your brain.
Oh yeah. It's
So-
also bad for your like lungs.
That too.
Well,
But
But isn't there like medical
Okay.
marijuana that's
Smoking
Yeah, that's
marijuana
different.
is worse than
different.
not smoking any.
Oh, I
But it's
thought like
better than smoking
I thought like
cigarettes.
recreational and medical were the same thing.
no.
No.
So recreational is you do it for fun. Medical is it has been made into medicine.
Oh, okay. So,
So,
it's like different.
Like it's been extracted, it's been modified. They can pull out the chemicals in it.
Oh, okay.
So that's like saying that like I forget what plant it is, but you can make opium with it, but you can also make opiates, which are like pain pills,
Oh,
like
that's
medicine.
my mom.
So-
She works at a hospital. She's freaking out because there's been an epidemic in Columbus of people overdosing on opium.
Yeah,
My
opioids.
brother taught
It's
me
really
where,
bad
like,
nationwide.
opium came from, like the Britons.
It's a plant. It just comes from a
Yeah,
plant.
look, it was the money, so they sold it to
Yeah.
people in India because
All right, so when we set this up and stop laughing about 420, then we have our volume. Now, are we good unit-wise? The question at the beginning tricked us with the units. Are we okay unit-wise?
Yes.
So length and width doesn't specify. The height does specify
It's
feet.
just feet.
This is feet cubed, so it looks like we're okay. So if I set up that I want my length of whatever it is, but I'm going to replace it with 2W because I know it's twice the W, times the width, times the height, equal to our volume. We're then going to get, right?
Well, then you would divide the. Well, you could like do the squishy thing. And make it
What do you want to do? I don't care what we do. What do you want to do?
Oh, okay, then divide by 2.
Ooh, you can do better than that.
Oh,
Brian.
I want to do as little work as possible, Brian. I'm lazy. I want to do as little work as possible.
Then you can switch to 2W and
Don't-
do it again.
Well, don't just divide by 3. If you want to divide by both multipliers, divide by 6.
Okay.
Because really, what you're dividing by, gentlemen, chill. What you're dividing by is the 2 and the 3 at the same time. So really, you're dividing by 6. That leaves W and W on the left side. So W squared.
70 is 7W. And then you add square root.
So the square root of 70. Now, in this situation, will the negative value that I get make sense? No. I can't have a negative length. So my W realistically only has one choice, one option.
8.3666.
And this would be feet. Sorry, no power, that dot, ignore that dot. So 8.4 if we round.
I'm sorry, I just read that.
No, you're good. But what I would actually do is take this value Okay, so before we rounded, which is obviously how the question asks it, but if we're going to talk about real math, what we'd actually do with this is convert it to inches to get a more accurate value. So we would take our 8.366 or whatever repeating value and just multiply it by 12 to get a more accurate inch reading. Preguntas? See, nope.
It's like,
I have a question. Psych, nah.
oh, dang,
He got
Calvin.
you.
Straight finessed you.
Call Calvin a finesse.
Calvin, never did I really think that you would be psyching people, but I like
Dang,
it.
Calvin.
Call Calvin a finesse, kid.
Try this on your own. I'm going to pass out your homework. Especially with us missing people, we're not going to move any further today.
Mental process.
Gentlemen, do your math, then talk.
Sorry, the horrible one with the guy.
Yep.
Are we doing all the questions?
Yeah, I don't think there's that one. Yeah, we should. We want to practice this because this is fairly important. And it should be relatively quick. What do we get for the width of our tank? Charlotte?
6.324.
Anyone verify?
I got mine. It was just a prank, bro.
You did not?
I got
Okay,
7.9.
Or no, I thought I got
7.9. Well, now we're going to check this work.
Go.
So, again, length is twice the width.
Yeah.
So we get 4 times 2w times w equals 500. So you do 500 divided by 8.
Yeah.
So you get w squared equals 62 and a half.
Oh,
Yeah?
that's where I messed up.
Square root of that gives us, what'd you guys say?
7.9.
Yep, never mind. That's where I messed
And
up.
a bunch of other numbers.
7.9 feet. If we round it. We all good? Any other questions?
Yeah.
Alright. Take some time on your homework. You got about 10 minutes? A little under. I guess like 8.